Guys, so today we're going to go over graphing square root and cube root functions. It's kind of the same as what you've done with a quadratic and absolute value in terms of ApoSamo. So again, just notice that I gave you the parent function for the square root of x, as well as negative amplitude, negative square root of x. And some key points: the square root of 0 is 0, so 0, 0 is a point. The square root of 1 is 1, so 1, 1 would be a point. And the square root of 4 is 2, so 4, 2 would also be a point. So there's some key parent function points for you to just use when you're using ApoSamo. So notice that the function for number 1 will say y equals the square root of x minus 1 plus 2. So using the ApoSamo method, it says minus 1, so that means I'm going to go opposite right 1. And then plus 2 means I go up or down, and I do exactly what it says, so up 2. So right 1 and up 2 from these parent function points, positive amplitude. So instead of 0, 0, I'm going to go right 1, up 2. And instead of 1, 1, which is right here, I will go right 1, up 2. And instead of 4, 2, I'm going to go to the right 1 and up 2. So that'll be my graph. Just keep in mind, I do not graph well with these. So just kind of keep that in mind. Now, if it asks for the domain and range, usually I ask you guys to solve for the domain algebraically, but domain are all the x values. So if you look at this graph alone, you can see that the x values begin at 1, because that's when the graph starts, where x is at 1, and it goes all the way to infinity. So my domain would go from 1 to infinity, brackets around 1 because it includes 1, or in set notation, x such that x would be greater than or equal to 1. If you were to solve it algebraically, all you would do is focus on what's inside the square root, because that's where one of the restrictions are, meaning you can never have a negative inside of a square root. So we need to make sure x minus 1, what's in the square root, would be greater than or equal to 0. So if I solve for x, I would get x is greater than or equal to 1. And notice that's exactly what I have for my domain. So in this case, you could solve for it algebraically as well as graphically. The range has to deal with all the y values that your function could be. So I'm going to start at the y values. So as I'm going up the y-axis, notice that my graph begins here where y is 2. And as this keeps going out, it will slowly and gradually go up as well, all the way to infinity. So my range would be 2, because it's included, it's in brackets, to infinity. And the range in set notation, y such that y would be greater than or equal to 2. So that's our square root graph. And now we're going to deal with the cube roots. So this is a parent function of what a cube root looks like. A parent function is when there are no numbers being added, subtracted, multiplied, divided to it. So this is just cube root of x. Notice some key points. Again, we have 0, 0. Another one is 1, 1. And also negative 1, negative 1. So from here, since we're taking the cube root of x minus 3 plus 1, we're still going to use ApoSamo. So if it's inside the parentheses, inside the radical, inside the absolute value, it will be Apo. So I'm going to do the opposite of what it says. Inside means you're going to left or right, but you do the opposite. So to the right 3 is where I'm going, and then Samo outside, anything added outside the square root, parentheses, absolute value, cube root. That'll tell you how many times to go up or down, and we do the same as it says. So right 3 and up 1 from these parent function points. So instead of 0, 0, I go to the right 3, up 1. Instead of 1, 1, I'm going to go to the right 3, up 1. And instead of -1, -1, I'm going to go to the right 3 and up 1. And it will have the same, oh, you're asking a lot here with the graph. It'll have the same shape, but the points just shift, they translate. So upwards and down and downwards, right and left. So that's why the parent function is important to know as well, just because you'll also know the shape of the graph. So now to find the domain, what are all the x values being used? Well, this goes out to -infinity all the way to +infinity. So my domain is all real numbers. Now, how can that be? When a square root, I have to be careful and make sure it's always greater than or equal to 1. Well, the thing about a cube root is you can always take the cube root or any odd root of a negative number. Those actually work. You just can't take the even root of a negative number. So fourth roots, sixth roots, you can't take the root of those of a negative number. But for odd, cube roots, fifth roots, so on and so forth, you can replace it with a positive, negative, 0, they all work, which means domain is all real numbers. Now for the range, if I look at the graph and I'm starting from, again, at the negative y-axis, as this goes out towards the left, it also heads downwards. So this starts at -infinity, and as I'm going up the y-axis, as this keeps going out, it will also gradually keep growing as well. So my range is going to be also from -infinity to infinity. And range has to deal with y's, y such that y is an element of all real numbers. And that's how you write it for the range. All right, guys, I hope this helps.